To solve this today's LeetCode problem. The question is number of atoms. So it's a hard problem. So let's see what the question is. So we have a given a string formula representing a chemical formula. Return the count of each atom. The atomic element always starts with an uppercase character, then zero or more lowercase character representing the same. Then one of more digits representing that element's count may follow if the count is greater than 1, and if the count is 1, no digits will follow. For example, S20 and S2O2 are possible, but H102 is impossible. Two formulas are concatenated together to produce another formula. For example, S2O2 and He3Mg4 is also a formula. So basically, these are the conditions given here for the chemical formulas. This is just a normal formulas which you have studied in class 11th and 12th. So here this is given the conditions that the first characters of each formulas can will be uppercase letters, and after that if there are more characters joins with it with the lower characters, then we can consider them as a, separate a same chemical elements, right? Like H2, like helium and magnesium. So first character is capital and all the rest characters are small, right? So basically that represent the same. After that, it can also be possible that we have given he2 or something like that. We don't have he1, right? Because this he is already representing a one elements. So if there are more than one element, so that will represent two greater than two, right? It can be also possible it will be 20 or something greater than that, right? So this is all represented in string. So and also there can be also parenthesis between them, like h2o2. So if there are parentheses and this is if there are parentheses and this is 3, so basically this 3 is multiply with this all this, right? So this will be like h6 o6, right? So this h6 and o6. So this is just a when you open this parenthesis, this 3 will get multiplied with all the elements presently, right? So this 2 will multiplied with 3, this will becomes h6 and o6, right? So this is the conditions are given for chemical formulas. So basically what we need to do, we need to return the count of all elements as a string in the following form: the first name in sorted order, followed by its count, then followed by the second name in sorted order, then followed by its counts, right? So basically what does it mean? So when you open this, let's take this example for better understanding. So when you open this k, this will be k4. When you open this first parenthesis, right, this first parenthesis, so this will become o2, this will become and this will become o2, this will become n2, and this is so3, right? So basically now this 2 will multiplied with all the elements which is present inside this parenthesis, so this will become 4, right? Now when you again open this will become k4, O2 and 2, and now this 4 will get multiplied with SO3. So S is present one time, so this will come S4. O is at 3 times, so this will become 12, right? Now if you, what we need to do, we need to count all the elements as a string after sorting on the basis of this elements, this K, O and SO, right? So now if you see here, K is present 4 times, right? O is present here 2 times plus this 12, which is 14 times, right? And n is present 2 times, s is present 4 times, right? So this is the unique characters which is present. So we need to sort it according to the alphabetical order, and then we need to write the number of count it present, right? So in k n s o, which is the smallest alphabetical, of course k, right? So k will be present, then it present 4 times, then n is present, it will become 2 times 20 times, right? uh, yeah, 2 times, right? Then o is present 14 times, so this will be 14. See, so this is not 0, this is o, right? This is not 0, this is o, right? So times 14, s is present 4 times, so this will be the final answer. The question is that, right? So basically we need to we need to find we need to remove the parenthesis and find the count of each uh, each elements chemical form, each elements with like helium, magnesium, and all chemical elements, right? It's chemical elements, and sort it according to their according to alphabets, right? According to the alphabets, and write their count in front of them, in front of them, of course, in a string, right? This all will be, this all should be in a string, and we will return this string. The question is that much, right? This much is the question, right? So basically this is something like parsing, right? This is something like parsing, and this is something like parsing, and doing parsing in C++ is very much hectic, right? The implementation part would be very difficult for this. I'm sure about that, because see, one thing is for sure, that when you see that this type of examples, when I do all the nested parentheses, like I put fe, this is two times present, and this is four times after that, three times after that, right? So this fe is one element, right? So first characters will be upper, and after that, if there is lowercase letters, then this all this all characters should be comes at the same word, right? This is all are the same one, and this fe is present two times. When you remove this parenthesis, this will become six. This will become fe6, right? So this is how we need to find out the uh, number of times the chemical elements are present in this formula, right? So basically how we will do that. So I told you, you see whenever you see whenever you see the pair like something, right? You need to pair something, pair like something, you think of a stack, right? You can think of a stack, right? So basically, in this, you see that we have a parenthesis, and when we need to remove, we need to uh, multiply it after values, close parenthesis, after close parenthesis, to inside of close parenthesis numbers of times, right? We need to multiply that. So basically, I need to know that yes, I have when I encounter close parenthesis, I have some elements present inside that parenthesis, which needs to be multiplied by the element which is present after this valid parenthesis, right? So we will use this stack, but how we will implement this? So one thing, if you see here, when you try to multiply this, when you remove this parenthesis, right? When you remove this parenthesis and this parenthesis, when you remove this, so basically all the elements get multiplied by this 2, right? So when you remove this o becomes 2 and becomes 2, this 2 becomes 4, right? This 2 becomes 4. So when you remove upper part, that the largest part of the parenthesis, the starting point and so that get multiplied, right? When you again remove this upper, the first part of parenthesis again, so this inside this parenthesis all get multiplied by 4, right? So when you remove this parenthesis, this will be 4. This o present times 12, so this will be 12. Now this 3 will also be get multiplied with 4, so this 3 will become 12, right? Now again when you open this 2 inside will get multiplied this 12. This is like 24, right? This will be 24 when you multiply it with 12. So this is the final formation, right? But we need to separate it according to the unique elements, according to the unique elements, which will be this k o and s. This will be s4, s o and fe. So o is common, so o is present two times and o is present 12 times. So basically you can write it like this. This will be 14, right? This will be 14. This is something like that, and all other elements is common, right? So you need to sort it on the basis of alphabetical, and just write in front of them the number of times is present. So you will do that, right? So but if you see what I have done, I have just taken I have what I've done, I have just done that. I started from the last part and multiplied all the elements with the number present after the parenthesis, after the close parenthesis, the number present I have just multiplied with all of them, right? And that is what I am doing again and again in this. I have started. I'm not starting from the inner part. I am starting from the outer part, right? So what we'll do, I will start from the outer parenthesis, right? Outer parenthesis, right? So from what does it mean? But I start with outer parenthesis. That I will start from the back, from the back. What I will do, I will start iterating from the back, from the back of the formula, back of the formula, right? That's what I will do. I will start iterating back of the formula, and when I will, if I get a number, if I get a number, I will multiply it with all the elements, with all the elements, with all the elements count with that number, with that number, right? That's what I will do, right? So but how we will do that, because its implementation would be not easy for sure, right? So main part of this question is just an implementation, right? Main part of the question is just an implementation. So how we will how we will solve this, right? How we will solve this and multiply this. So basically, one thing is sure, that I need to multiply it and also store in, like, uh, from the part. And one thing also sure, that I need to just I need to just take care of the elements which are present greater than one, because one is not present. One is not present, like the alphabetical one, the character one, right? The number greater than one is present, representing as character two or three, four, like this. Right? Okay. So what I will do, I will start from the back. I will start from the back, right? O of n. Let's take a small example. Okay, just take this example, right? This is a very good example to show you the characters. So what I will do, I will start from the back and start iterating in this, right? So I will start from the back, and this k4 will be O of n, and this is so3, right? This is so3, this is so3, right? And this is 2. So when I start from the back, I get 2. So when I got a number. So one thing's for sure, whenever I get a close parenthesis, I need to multiply this number with inside of that one. So when, so if, let's make the condition, right. First case is when if the characters, if character is, if character is close parenthesis, I need to do a multiplication of the this number. This will be the current number, right? This will be the current number. So we can take this current number, this current num as a 2, right? So we need to multiply this current number with multiplications, right? With the multiplication. So I can take a multiplication. If this is the final multiplication, right? This is the final multiplication which we are multiplying, right? So this is initialized to be 1, because if you initialize with 0, this will be give 0. So you need to initialize with 1. So this needs to be multiplied with this this multiplication 1, right? So this will be gives us 2, right? Whenever I get a small parenthesis. Now what will need to do, we need to just uh, see that whether this we need to see that whether this current num is applicable to or not, right? Applicable to or not, right? So we will take the help of a stack, that whenever I will get a close parenthesis, I will just uh, multiply it with the final multiplications. So this multiplication will be common with all the elements, right? This is the current nums for the only the for the particular parenthesis, but this multiplication will be all uh, for all the elements which is, for all the characters which is present in this, right? So we will take a help of this. So, and also I need to take care of this current num, because this, whenever I get a close parenthesis, it means for sure that I will get definitely a small parenthesis, right? Sorry, open parenthesis whenever I get a close parenthesis. So I need to take care of this current num also, because if you see here in this 2 is multiplied with this within this multiplication, but before this open parenthesis, this k4 must not be multiplied with this 2, right? this needs not to be multiplied with 2. So we need to uh, we need to divide this by 2 to this the final multiplications value, right? This needs to be divided by final multiplication value. Let's take as a final multiplication. That's why I need to store it also, right? So let's just finally see that we have multiplication, right? Now the final multiplication is 2 right now after this multiplication. Okay, so we need to take care of this multiplication part, right? So this final multiplication is 2 till here, right? This till here. Now when, and this current multiplication, which is the 2, is also stored in my stack, right? This is also stored in my stack, right? Now when I got inside it, we have now this current num as 2, right? We have got till this 2. So the current num is 2, right? Current num is, so basically we have removed this close parenthesis, and current num is 2 here, so we will store this 2. Now this final multiplication is before 2, and now current number is 2, and also we again got a close parenthesis. It means this needs to be multiplied. So what we will do, we will change this final multiplication to 4. Oh sorry, this to be 4, right? Now we got close parenthesis, so we multiplied it with 4, and this current num will be again empty. Now this so we need to also store this current count with 2, because when we got open parenthesis, this needs to be divided by this element. So now the final multiplication is 4 here in this, and we removed this parenthesis here from the here, right? Now one thing you note here, that this this is still, we got a 3 number, right? This is 4, and this is a closed parenthesis. It means the current num, what that would be, it would be, that would be must 3, and that would be for o value. This is for o value, right? This is for o value. The current num value is 3 for o value, and the final multiplication is 4, right? Now when you see here, this current num is 3 and final value is 4. This, and this o is the capital value, right? It means this is a one element only, this is one element. So this should be multiplied, the number multiplied with 4, and that will be 12, right? That would be 12. So if that would be a 12, it means the element o, a number is a 12 element, right? And this 4 is common with for o, for s also, for both. So what we need to do, we need to store the oth count as the oth count as 4 3 the 12, right? Now see, the current number is 3, and when we got a capital number, it means when we got when we when the character is a capital number, right? That is uppercase, character. Then what we need to do, we will just we will just count the number and store it in our elements, right? We will just take multiplication of its current count with the final multiplication number, and store it as in our dictionaries or anywhere you want, right? So I have stored in dictionaries, right? O12, right? So now the thing is, this this is becomes O12, right? This is becomes O12. Again when we move to s, this s is only 1, this s is only 1. So the current num is for this s is 1, and multiplication is 4. It means, and after this, just this s is also a capital number, right? S is uppercase character. So s do not have any element, so s is 1. So current num is 1, and final multiplication is 1. So s will have the count as a 4. So this will be current as 4, right? Now this, we got a small parenthesis, sorry, open parenthesis, right? When we see the open parenthesis, so this 4 multiplication is only for so3, but for on we only have this 2. For this 2, this on will be done. This 2 is for so3 only. So that's why whenever we see whenever we see this open parenthesis, I will check that whether in my stack we have some elements or not, because this is representing that when I have multiplied from which elements I have multiplied, from which number I have multiplied the whole parenthesis when I am encountering the close parenthesis, right? The close parenthesis. So when I'm encountering the close parenthesis, I have multiplied it. So when I encounter a small open parenthesis, I need to divide it by the number which I have multiplied when I encounter close parenthesis, and that number would be stored in my stack. That is last value. This is 2. So when I encountered with this number, the open parenthesis, I need to divide it by the last value, and final multiplication would be 2, right? The final multiplication will be 2. Now the final multiplication is 2. It means this O1, we need to see for On as this problem is solved for SO3, right? Now this for On final multiplication is 2, and for N the current term will be 1 because it is present only one times, and also this N, this N is a capital letter, and when you see the when you get uppercase character, okay, when you, I need to write it for small parenthesis, that when you get an open parenthesis, what will you do? We need to we need to uh, divide the final multiplication with the number present at top of the stack, top of the stack. The reason is that when you encounter the close parenthesis, we have multiplied it, but when you encounter the lowercase the small parenthesis, you need to also divide it, right? That's the reason. So this need to be done, right? And we change the final multiplication value whenever you encounter the open parenthesis, right? And also you will need to delete it from the stack, and delete the number from the stack, right? That's need to be done. Okay, now uppercase characters done, open parenthesis done, and close parenthesis done, right? That's done. But one thing can also happen, that in some cases there will be lowercase characters, right? Lowercase characters. In that case, what need to do, no, what need to be done? Nothing, because suppose instead of this O of n, okay, let's complete this. This n is 1 times present, and final multiplication is 2, so this n will be present 2 times, right? So that will be present 2 times, right? That is present 2 times. Same for O, but you see that this O is present 1 times and final multiplication is 2. This will be 2 times, but we have already O count, right, in my dictionaries. So that will be 12 plus 2, which is 14, right? This will be 14. Now O of n is now we are again encounter a small open parenthesis. So this we check the stack, we have a number, so this needs to be divided by this final multiplication, so this will become 1, and this to be deleted, right? So this is over. Now we have current num as 4, so we will change this current num to 4. We have final multiplication as 1, so 4 into 1, which is 4, so k will present 4 times, right? K will present 4 times, and these numbers are over. So ultimately we have got these numbers, and we need to sort it according to the alphabetical order. So first thing is k, its number is 4. Second is n, its number is 2. Third is o, which is MNOPQRS, MNO, right? O, and its number is 14, and last is s, and which is number is 4. So this will be the final answer, final string, right? Okay, one thing is left with the lowercase characters. So suppose instead of this O, or there is number fe, right? There is a number fe instead of O. So whenever I got a lowercase character, it means that lowercase character will be the part of the whole fe. This must be a part of whole fe. So what will I need to do? I need to take a temp which is representing an element, right? Which is representing a particular chemical element. So what I need to do, whenever I got a small parenthesis, a small lowercase letters, a small alphabet, I will just append the characters in my temp value, just like this, right? I will just append the character in my temp value, because this will be a part of uh, the one chemical elements, right? Because this will be a part of one chemical element. This will be a part of one chemical element, right? So yeah, that's what uppercase characters needed, that whenever I got uppercase character, I will multiply of its current count with the final count. So this is just an implement, this is how we will implement this. And you see that I will use this just same thing in my implementation, right? So one thing is for I will make you clear that this things to be logical thinking in interview is very hard, right? If you're not able to think, don't worry. This is this type of questions is hardly asked in any interviews, right? In normal interviews, this is asked in somewhere in Google and Apple's 1 2 years ago, right? If this question comes in your interview, implementation is very hard, because at that time pressure, there's a lot of pressure in your mind, right? So yeah, we will implement this. The first thing is what we need to do. The first thing is to make some variables. So first variable is of course the size of the formula, right? So we will have stored size. The second is the current num and the final multiplication. So the final multiplication should be initialized with 1. Okay. Also the current num, this current num, where is current num, this is current num, right? So this current num must be initialized with something. So this current num, take it as a uh, take it as a string, what, right? Take it as a string because we have a string. So what we need to strike, this needs to be empty. Also I need to take a variables which for storing this temp, which is representing a particular chemical element. So I will take that also. So let's take this as a temp, or take as a chemical element, right? No, okay, let's take as a temp, right? Let's take as a temp, right? So basically this is representing current num and this is representing chemical element, right? Now what need to be done, we need to also take a stack uh, for checking it whenever I got for storing the for maintaining this final null. Whenever I got a open parenthesis, so I will take a stack which with we end. Now also I need to take index from where we started and minus 1, right? Now what I will do, I will just start from, let's take I is equals to n minus 1 greater than 0. And let's remove this, right? And now what I need to do, uh, I need to just move in negative fashion, right? In reverse order, right? So first thing need to check that whether what is this. So if this is a small letter, is a lower letters, right? If this is a lower characters, so this is lower characters, either you can write like this or you can write like this. Is lower is a inbuilt function in C++ library, or you can write like this. For if you don't want to use inbuilt function, you can also write like this if it is a small characters. So the formula I is less than equals to z, right? This both is correct. Either you can write is lower or you can write like this. So if this condition satisfied, it means this is a part of the temp, right? So we need to just append it. And how will we append? So we are moving from back direction, right? So we need to just add this formula in starting in starting of the temp. This needs to be add in starting of this temp, right? So what need to be done? So suppose if temp is something like z, this like this, and you need to add a at front part because we are iterating from the back. So so a plus kd, this is something like a plus kd, right? Like this. So this is temp formula I plus temp, right? Now this is if this is a lower. And what if this is a digit? What if this is a digit? So for representing digit, there is a inbuilt formula for this. So if this is a digit, if this is a digit, so for this you can write like this. Also you can write like formula I minus 0 must be greater than between 0 to 9, right? That's also represented. I'm just using this, right? So if it is a digit, it means this would be a current num, part of the current num, right? This would be part of current num. So same thing for current num, that if this is a formula, so you need to append it at first part, and then you will append the whole string of num, right? Because we are iterating in reverse order, right? So this needs to be done. Now lowercase handle, so lowercase handle, digits handle, right? Digits handle. Now what left? There were four conditions, right? Lowercase, okay, now parenthesis and also upper cases. So what if there is uppercase letter? So if formula I is greater than a and between z, right? Between z. So if this is between a and z, what needs to be done? So see, if this is between a and z, we need to take multiplication of the current count with the final multiplication, right? So what we need to done, we will just take the final multiplication in the uppercase part. Okay, so what we'll do, we will take this temp, we will store this formula I, because this needs to be uh, added in my total elements, right? So this will be formula I plus temp. Also I need to multiply it with my final multiplication. So final multiplication, uh, the final multiplication must be check that this current num, if it is a empty, suppose there are no there is no any digit present, it means the current num must be 1, because the number 1 is not representing here. So if the current num is empty, so how will it will write, we will write current num is empty. If this is empty, it means the current num must be initialized to 1, right? Must be initialized to 1. So we will just initialize to 1, right? Now, now I need to store the count of this particular temp value, right? Because I have encountered with az, so we need to multiply it with the current num, with the number present at the top, with the number current count, and store it in dictionaries. So here I will not take in an error map, like just make a dictionaries to store the final count, right? This should be a string, so I will store this as a string. Now this mp, what will this mp do? This will store this temp with, okay, this current num is a string, so it needs to be changed to the number. So this is twice changes from string to the number, and it should be multiplied with the final multiplication, which is I have which I have in whole maintaining, right? So this need to be stored, and this needs to be added because it can be present multiple times. So this is added by adding plus. Also, when I got the upper part, the current num will be initialized to the empty part, because now the current num's work is over. Also also the temp one, this temp is also removed. This needs to be also initialized with the empty part, because this his work is also left, because we got a particular element and its count, and we have stored it, right? So this the current num over, the temp is over, right? And we have also stored the count, right? Now uppercase handle, see, you just see that implementing this in interview is very tough, right? I agree with you, but yeah, this is the question, that's why it is hard problem, right? Now the last one, not the last one, we have now left with the parenthesis. So what if we have parenthesis? So formula I, what if it is a close parenthesis, right? What if it is a close parenthesis? So if it is a close parenthesis, what if it is a close parenthesis, right? Or I have written, yeah, if it is a close parenthesis, I need to do a multiplication of the current num, right? I need to do a multiplication of the current num. So either you can write it in upper part or lower part, you want you. So what I need to do, I need to just multiply it with the square part. But before multiplying this current with current num, I need to check whether this current num is empty or not, right? Just we have done this like this here, right? So we will just do this, and if this is an empty, so we will just initialize with 1 to simplify it, right? Also I need to uh, push this current num value in my stack, because I whenever I encounter the open parenthesis, I need to divide it. So what I will do, I will just push it in my stack, and what would value will be. So let's take this as a int val, and this current will be the num, and store this as a value here, and also multiply it with the final value, right? Let's do this, right? So this is how we will do that. And also the current num value is over because we have got a close parenthesis, and current num is over, so we will just initialize this to the empty one again, right? Because its work is over, right? Now one thing is left now only, when I will got open parenthesis, right? So this is simple. When I got open parenthesis, it means I need to uh, make this final multiplication as before. So for that I need to just divide it by the number val. So let's make this val as a st dot top, which is st dot pop. Also I need to remove this, so I will just divide it by multiplication, right? So this is how we done. This final multiplication will be at the previous one. So we have handled all the cases. This is open parenthesis, this is close parenthesis, and this is open parenthesis, right? So this is how we solve the question. Now some part is all still left. One thing you have seen, that I need to short it according to the value, according to this value KOS2, right? So, and I am storing this temp, right? So I need to short it again, right? So I have taken unordered map. So instead of this, if I take a map, this will short it for me automatically, because map stores the alphabet, so stores its key in sorted order. So instead of unordered map, if I take map, this will give me all the in sorted order. I just need to store in my answer. So what I will do, I will just take an answer empty value, and I will just iterate in map. I will just iterate in map, and I'm sure about that if I have taken a map instead of another map, this is string, this will give me in sorted order in on the basis of the elements. So what I will do, I will just store this its first part. Also I need to store its count after this, but I will store only the uh, I will store only those numbers which is greater than 1. So it dot second, if it is greater than 1, I will store its value also. So this is it dot second is a num, so I need to typecast this. So this needs to be converted to a string. So I typecast this, and now this answer should be done at last, right? So let's try to run this. I hope so there can be a compilation error, so we will see that. Okay, line number 32, this need to be done, this needs to be done. Okay, let's just run this again. I think now this should be work fine. We have passed all the sample case, let's submit it. Yeah, we have passed all the test cases. So basically what is there, the question is simple, but the question is the question logic is simple, but the implementation is hard. That's why the question is hard, right? Implementation is hard. That how will you implement this thing, right? From iterating back and maintaining this current temp, this clean code must is a hard in interview. I don't worry about that. We all have faced this, we will all face this problem. So don't worry about, don't take tension about that, but this is how you implement this, right? So first thing is to handle the lowercase. If there is a lowercase, we will just take the maintain this temp. If this is a digit, you need to just maintain current num. If it is uppercase, it means till now you have count all the digits of this particular element, and also you have stored the temp real temp value, right? And now you just need to multiply it with by final multiplication and store its count, because finally you just need to return the count of that, right? And if you have done all this, the current num is free, right? This current num is free because this needs to be changed by for other chemical elements, and this temp should also be free. When you get a close parenthesis, you need to update the final multiplication value, right, with the numbers which is present before it, so you need to multiply it with that. Also you need to store it, because whenever you get open parenthesis, you need to backtrack the final multiplication to the previous one, right? And after that you just need to store the one which is greater than one, so you need to store that and return the answer, right? So this is how you solve this problem. Basically the time complexity, if we analyze, so first thing is that you need to iterate in whole of O of n for sure, right? The second thing, that for each insertion, see, we need to insert this before temp. So for that, this formula is O of 1 plus this temp will take O of n, right? Same for this current num, same for this temp. So for each insertion you are taking again O of n, O of n, O of n. So that will take O of n square for sure, right? So that will be O of n into O of n, that will be O of n square, O of n square, plus you are taking a map and storing a string, that will take O of n log n, because this will store in sorted order, so that will take O of n log n. So overall it's a O of n square, and the space complexity would be, so the space complexity would be here, would be, if you see here, we are taking a stack, we are taking a map, right? So if you take a map, we need to store all the strings, that will definitely take O of n. If you take a stack, we are just storing the values which can be taken as O of n if you want, because there can be possible that there are many parentheses, right, in the first. So basically overall it is a O of n, right? If you analyze, that is O of n. So this is the time in the space complexity. Hope you uh, hope you get understand it, right? So thank you so much. Thank you so much. Bye bye.